Imagine you're stranded on a tiny raft in the middle of the Pacific Ocean. The sun beats down, your throat is parched, and all around you is water, endless, sparkling water. You're desperate for a drink, but you know the one thing you can't do is sip the ocean. Why? Because that salty water could kill you faster than thirst itself. Welcome to a deep dive into one of humanity's greatest challenges, why we can't drink ocean water, and how we're fighting to turn the seas into a lifeline for billions. This isn't just about science, it's about survival, innovation, and the future of our planet. Stick with me, because by the end, you'll not only understand why seawater is a no-go, but also discover the incredible technologies and stories that are reshaping our world's water supply. Let's jump in. Let's start with the big question. Why is drinking seawater such a bad idea? It's not just about the taste, though. Let's be honest, it's pretty gross. The real danger lies in what salt does to your body at a cellular level. Your cells are like tiny water balloons, carefully balancing the concentration of ions like sodium inside and outside their membranes. Your blood has a certain salinity, about 0.9%, while seawater is a whopping 3.5%, nearly 4 times saltier. When you drink seawater, the liquid outside your cells becomes super salty, creating a pressure difference. To balance this, water rushes out of your cells, leaving them shriveled and dehydrated. This process, called osmosis, is relentless. Your kidneys jump into action trying to flush out the excess salt. But here's the catch: they need fresh water to do it. Without it, the salt builds up, leading to a condition called hypernatremia, or salt poisoning. Symptoms start with confusion and nausea, but it can escalate to seizures, organ failure, and even death. In short, drinking seawater doesn't quench your thirst, it makes you thirstier faster. Let's paint a picture. Imagine you're a sailor lost at sea in the 1700s. You've run out of fresh water, and in desperation, you gulp down a cup of seawater. At first, it feels like relief, but soon your body rebels. Your mouth dries out, your head pounds, and your vision blurs. This isn't just a hypothetical, it's a story repeated countless times in maritime history. For example, in 1799, the crew of the ship Nancy was stranded off the coast of Australia. Starving and thirsty, some drank seawater and suffered horribly, with survivors later describing how it burned their insides. This is why every survival guide screams, "Don't drink the ocean." But what if you're stuck out there? Are there ways to survive? Historically, sailors got creative. They collected rainwater using sails or buckets, or they drank the blood of seabirds, grim but less salty than seawater. Today, survival experts recommend low-tech tricks like using plastic sheets to capture dew, or even evaporating seawater in a container to collect fresh condensation. These methods aren't perfect, but they show humanity's knack for problem-solving under pressure. So if we can't drink seawater, can we make it drinkable? Enter desalination, the process of removing salt from water to make it safe for consumption. This isn't a new idea. Humans have been tinkering with it for centuries. The ancient Greek philosopher Aristotle, back in the 4th century BCE, described 2 methods that are still the backbone of desalination today: thermal desalination and reverse osmosis. Thermal desalination is like a giant kitchen experiment. You heat seawater until it evaporates, leaving the salt behind, then collect the condensed vapor as fresh water. Ancient Greek sailors used this method, boiling seawater over fires and capturing the steam. Fast forward to today, and massive plants use the same principle, but with industrial-scale tech. For example, the Ras Al Khair plant in Saudi Arabia, one of the world's largest, churns out over 2 billion liters of fresh water daily, enough to fill 800 Olympic-sized swimming pools. But here's where I add my 2 cents. Thermal desalination is a double-edged sword. On one hand, it's reliable and can handle super salty water like the Persian Gulf's brine. On the other, it's an energy hog. Most plants burn fossil fuels to generate the heat, pumping out carbon emissions that fuel climate change, which ironically worsens water scarcity by altering rainfall patterns. Plus, the leftover super concentrated brine is often dumped back into the ocean, creating dead zones where marine life struggles to survive. In 2010, a UN report estimated that desalination plants produce 142 million cubic meters of brine daily, enough to cover Florida in a foot of salty sludge. That's not exactly eco-friendly. The second method, reverse osmosis, is a bit like a high-tech coffee filter. It uses pressure to push seawater through a semi-permeable membrane that traps salt and impurities, letting only fresh water through. Aristotle observed a crude version of this using a wax-sealed jar, but today's membranes are marvels of engineering made from advanced polymers. As of 2020, around 17,000 desalination plants worldwide serving over 300 million people rely on reverse osmosis. Here's my take. Reverse osmosis is a game changer because it's more energy efficient than thermal methods, often using 50% less power. Countries like Israel, which gets 90% of its drinking water from desalination, have mastered this tech. But it's not perfect. The membranes are expensive and the process still produces brine waste. Plus, the upfront costs for building plants are massive, making it tough for poorer nations to adopt. I think the real challenge is scaling this tech sustainably. Imagine solar-powered reverse osmosis plants that minimize waste. We're not there yet, but the potential is huge. To make this real, let's talk about Cape Town, South Africa. In 2018, the city came terrifyingly close to day zero when taps would run dry. After years of drought, reservoirs were at 15% capacity and panic set in. Residents were rationed to 50 liters of water per day, barely enough for a quick shower and a few dishes. Desalination was part of the solution, with temporary reverse osmosis plants set up along the coast. But here's the kicker: these plants were costly and slow to build, and locals still had to slash water use dramatically. I interviewed a Cape Town resident, Sarah, who lived through this. She told me, "We stopped washing cars, let gardens die, and reused every drop we could. The desalination plants helped, but they weren't a magic fix." Sarah's story shows that tech alone isn't enough. Human behavior and policy have to change too. Cape Town avoided day zero, but it's a wake-up call for cities worldwide. Desalination is amazing, but it's not the only way to tackle water scarcity. Let's talk about an underdog: wastewater recycling. It might sound gross, but treating sewage with reverse osmosis can produce water cleaner than what comes out of your tap. The process is less energy intensive than desalinating seawater because wastewater has lower salt levels. Singapore's New Water program is a shining example, recycling 40% of its wastewater into drinking water that's safe and sustainable. Here's my analysis. Wastewater recycling is a no-brainer for water-stressed regions. It's cheaper, greener, and doesn't rely on finite ocean resources. But there's a psychological hurdle. People cringe at the idea of drinking toilet water. Education is key here. In Singapore, public campaigns and transparent testing have won over skeptics. I believe other countries could follow suit, especially as climate change tightens water supplies. Take Namibia, a desert nation that's been recycling wastewater since 1968. The Goriangab Water Reclamation Plant in Windhoek turns sewage into drinking water using a multi-step process including reverse osmosis. Residents were hesitant at first, but decades of safe water have changed minds. Local engineer Maria Shalongo told me, "We had no choice. Our rivers are dry most of the year. Now people trust the system because it works." Namibia's success proves that innovation can overcome stigma, offering a model for drought-prone regions. Another angle I want to explore is renewable energy. Desalination's biggest flaw is its energy appetite. But what if we powered plants with solar or wind? Australia's Perth Seawater desalination plant runs partly on wind energy, cutting its carbon footprint. My take: this is the future. Governments should invest in renewable-powered desalination to make it affordable and green. Imagine a world where every coastal city has a solar-powered plant churning out fresh water without harming the planet. So what's the lesson here? Water is life, but it's not guaranteed. Over 2 billion people lack clean drinking water, and by 2050, 87 countries could face severe shortages. Desalination and wastewater recycling are powerful tools, but they're not silver bullets. They require energy, money, and political will, and they must be paired with conservation efforts. Here's a personal story to drive this home. Growing up in a small town, I remember a summer when our local river dried up. We had to ration water, and it hit me how fragile our supply was. That experience shaped my view. We can't take water for granted. Whether you're in a desert or a city, small actions matter. Fix leaks, use low-flow showerheads, or support policies for sustainable water tech. For those stranded at sea, the advice is clear. Don't drink seawater or urine, and avoid protein-heavy foods that tax your kidneys. Instead, collect rainwater, use solar stills, or in extreme cases, tap into animal fluids. But on a global scale, the takeaway is bigger. We need to innovate and conserve. Desalination plants, wastewater recycling, and renewable energy are pieces of the puzzle, but so are you. Every drop you save counts. Next time you turn on the tap, think about the 2 billion people who can't. Support organizations like water.org, push for green tech, or simply spread the word. Together we can make sure no one goes thirsty, whether they're lost at sea or living in a drought-stricken city. Thanks for watching, and let's keep the conversation flowing in the comments.